Ooh, so now we got special cases. So we had some special cases earlier when we solved using graphing. We had 2 special cases. Now we're going to see what these special cases may look like in an equation form using substitution. So I still need to get one of my letters alone. I have an x, a negative 2y, a negative x, and a positive 2y. I'm going to solve for that x in equation 1. So if I add 2y to both sides, I get that x equals positive 2y minus 4. Now if I'm going a little fast, feel free to pause this video, take some time, write the slides down, write what you need to write, and then press play again. That's the beauty of videos. So I have x equals positive 2y minus 4. So I'm going to take this 2y minus 4 and substitute it in for x in equation 1 or equation 2. So I have negative x, well x is 2y minus 4 plus 2y equals 2. So distribute that negative, I get negative 2y plus 4 plus 2y equals 2. Well, I have some like terms and they're on the same side of my equal sign. Negative 2y plus 2y. Well, what's negative 2 plus 2? Isn't that just 0y plus 4 equals 2? And isn't 0y just 0? So these actually canceled each other out, and I'm left with 4 equals 2. Well, does 4 equal 2? Nope, 4 never equals 2. Since I ended up with something that wasn't true, I ended up with 4 equals 2. 4 equals 2 is not true. I have no solution. Meaning these lines are actually parallel and they're never going to cross. So no solution happens if you end up with one of your variables canceling and a statement that's not true, like 4 equals 2. 4 will never equal 2, so I have no solution for this one. So this is a special case. How many solutions do I have? No solution. So special case number 2, let's get a different color here. You know me and my colors. I like to spice things up. I have y plus 1 equals negative 2x, or 2x plus y equals negative 1. Well, if I'm trying to get a letter by itself, let me get the y from equation 1 by itself. I have y plus 1 equals negative 2x. If I subtract 1 from each side, I get y equals negative 2x minus 1. So let me substitute this piece, negative 2x minus 1, from equation 1 into my y in equation 2. So I have 2x plus negative 2x minus 1 equals negative 1. Some of you guys may be seeing something. 2x minus 2x minus 1 equals negative 1. Well, 2x minus 2x, they're on the same side of my equal sign, so I just combine them using like terms. Well, 2 minus 2, those cancel out, and I get 0x minus 1 equals negative 1. Well, 0x is just 0, so I get negative 1 equals negative 1. What's different about this solution, or what happened in this case, compared to my last case? Does negative 1 equal negative 1? Yeah. Negative 1 will always equal negative 1. So if I solve using substitution and my variables cancel, but I end up with a true statement, I have infinitely many, or an infinite number of solutions. I have an infinite number of solutions, or infinitely many solutions, because I solved using substitution and I ended up with something true. -1 will equal -1. So any x or y, any point that I put into this system, or those equations, will give me something that works because these are actually the same line. So this is special case number 2. What you guys are going to do is try some of these on your own. So flip your sheet over. If you don't have a sheet, here are your problems. Good luck, get going, and we'll check them off in a few.